we are going to learn more about how current works and what it actually looks like. So I'm going to use the same 6-volt battery, the same LED, but we're going to first try it with the 1000 ohm resistor and with the 100 ohm resistor. So we're going to change the variable, which is the resistor, in order to figure out what that means for current in our circuit. So in order to understand this, we need to first understand Ohm's law. So Ohm's law is V is equal to I times R. So voltage is equal to current times resistance. So if I don't know what volts is, then I get my current and I multiply by my resistance. If I don't know what my current is, then I get my voltage and divide it by resistance. And if I don't know what my resistance is, then I get my voltage and I divide it by my current. Okay? So what you're seeing here is we're going to run it twice. We're going to build the circuit twice. So first the circuit is going to have 6 volts. It's going to have 100 ohms, and I'm going to expect amps of 0.06, okay? And then I'm going to do it again with the same 6-volt battery, but a 1000 ohm resistor, and I'm expecting a smaller value for my current, right? And combine the topics from our last couple videos into a hands-on circuit that we're going to build on this breadboard. Okay, so you get the battery. The positive end is going into the positive rail here, the plus sign, and the negative sign or ground is going into the negative rail here. So this is what it looks like when the breadboard is powered up. Okay, that's this battery component. So if I follow my circuit diagram, I go to the resistor. The first resistor, A, is 100 ohms. So I'm going to go ahead and grab this. I'm going to connect it so this end gets its own row and this end gets its own row. So 20 and 25 get their own row with the lead of the resistor in there. If I followed the diagram next, then I get to LED. If I look at the LED, there's a short end and a long end. The short is negative, the long is positive. Okay, so I'm going to go ahead and stick that in to the board very similarly, but on the opposite side of that big valley. Okay, so now if I look at my diagram, what I'm seeing is this. I'm seeing a floating battery, a floating resistor, a floating LED. Okay, so why is a breadboard important? Because it helps us connect all these components easier using just a wire. So I'm going to go ahead and get this red wire, connect it to the power rail, so anywhere on that column, and I'm going to connect it to the top, which is 20A or 20C, D or E. All of those will work, but I'm going to use 20A because that helps me see my circuit a little bit better. So what that wire is going from the battery into the resistor. All right, so now the resistor needs to connect to the LED. How do I do that? I'm going to get this blue wire. I'm going to the same row, so 25, I can use A, C, D, or E, just like I mentioned earlier. I'll use E just to show you the difference. And then I cross the valley and I'm looking at the bottom of this LED and I'm going to put it in the same row like that. Okay, so now that that's in a row, this resistor is connected to the LED. So how do I close it up? How does the circuit actually work? You need to complete the circuit, and to complete the circuit, the electricity needs to flow all the way around. So what am I going to do? I'm going to add this last wire, and what I'm expecting to see is current flowing through this LED, and boom, I connect it, I close the wire, and now I see the current flowing in this LED. According to my math, with 6 volts, right, 100 ohm resistor, then my current is 0.06 amps, right? So if I were to get my multimeter here, we're going to measure touching one side of the LED and then touching the other side of the LED. I got 61.3. So if I write that down, 61.3, right? But now looking at this magnitude, I need to shift over 3 zeros. So what does that look like? 0.0613 amps. Okay. So this reading is very close to what we calculated out using our Ohm's law. Okay. So now we're going to do the same exact circuit, but we're going to use the second resistance B, which is 1000, which is a magnitude of 10 larger than this original 100 ohm resistor, right? So what I'm seeing is when I put more resistance, my current goes down. So what does current going down look like? Okay, so I'm going to take away this blue wire right here, and I'm going to go ahead and change out this resistor. Instead of 100, it's going to be 1000 ohms, okay? And then once I get my 1000 ohm, right, so let me take out this resistance, 100, I'm putting in my 1000, right? So boom, I connected it, and now I'm going to get the wire, and I'm going to close up from the resistor to the LED, and I should be seeing a different current. Boom. What does that look like? What'd you notice? The light is dimmer. The current is smaller. And so when I measure it, I should be expecting to see a smaller number to represent the smaller current, right? So here I am. I touch one side, touch the other side, and now what do I get? 6.2, right? The other one I got 61.3, and this one I'm getting 6.2, right? So when I read this 6.2 is actually translating into 0.0062 amps. So again, our reading comes out accurate to our calculation. The main thing you need to learn from using Ohm's law is when I have a voltage and I have a specific resistance, then it's going to affect my current. In this case, low resistance makes a brighter light or more current, right? And more resistance means a lower current or a dimmer light. So that's just a kind of a relationship that's very fundamental to understand, is that depending on what kind of resistance, you're going to get different current. Depending on your current, you're going to get different voltage. Depending on your voltage, you're going to get different resistance. So understanding really that triangle, voltage is at the top, current times resistance will give you voltage, and the relationship will always be Ohm's law, which is V is equal to I times R. All right.